hello to whatever poor soul is watching this. Thank you for watching this. We are all band. So I'm Connor, and that's Ryan, Dan, and Javi is behind me. And we're gonna present to you a problem and a solution that we hope you like. Okay, so outline for the presentation. First, we're gonna talk about the need. We're gonna go ahead and propose a solution. We're gonna get a little more in depth, talk about the tech specs. We're going to talk about the progress that we've made so far. We're going to look at the cost and the market. And then finally, we're going to talk about what we would do if we were actually developing this into like a real full-fledged product. So y'all have heard this a million times before, but every year in the US, almost 1 million children, 12 to 17, are at risk from suffering from anaphylaxis. Now, this doesn't constitute a huge portion of the mortality risk. It's about 1%. But 1% of 12 to 17, 1% of 10 to 30-year-olds, that's still a pretty big number. That's us. You know, that's me and my teammates. That's my classmates. And so in situations like this, where you have the possibility of a very severe event happening, even though it's not very common, the thing that you look for most, the thing that you're careful most about, is quality of life. So that's what we're looking to preserve with our solution. So the way that we think is best to solve this problem is it's a wearable. So it's a lot like a smartwatch. It's dumber in a lot of ways and it's smarter in the important ones. So the way that it works is if a child experiences an allergic reaction, they can push a button. There's a one-button interface on the faceplate that will notify a caregiver and emergency responders that they need help. It also integrates biometrics to try to automatically detect any sort of, I don't know how to best say it, any sort of strange things happening. At first, we thought maybe we could detect this automatically. We did a little more research and found that there actually isn't a combination of sensors, no matter how expensive or how many, that can accurately detect anaphylaxis, hence the manual approach.
Great. Yeah. So now let's talk a little bit more. As discussed in our past demos, we've implemented a web interface featuring crucial data about the patient. Next slide. So one of the most crucial part of our projects was to design a proper flow for the user and to help visualize a typical user's behavior as well as track the flow between software and hardware. We've developed this chart. So let's zoom in a little more to walk through the process. Our device allows a user to push a button. The wrist-worn device's internals contain embedded Arduino code that waits for the user to push a button. Next slide. Once the button is pushed, he or she will receive a text message with vital information, including a link to the web interface. At the screen, the user is introduced to a login form. Next slide. If the user does not have an account, he or she can sign up by registering a unique phone number. Once they are logged in, a patient or a caretaker with the account credentials can access live biometric data. And even more importantly, next slide, the map, which features the location of the patient. Next slide. To store the user data, we spent this past semester hooking our software up to a robust backend offered by Google Firebase. We chose this backend because it provides real-time database live changes every time new information is being inputted. Additionally, they provide encrypted key data by default, allowing our product to be compliant to several data security codes. Next slide. Great. Yeah. Ryan?
Right, so now we're gonna move on to the specs and the evaluation. So as mentioned later, we'll be collecting vitals. Our three most important are heart rate, dissolved oxygen, and temperature. Of course, we also need the GPS location so that the caregiver can actually find the user when the user presses the button. This means that we will require cellular access as well as texting capability and being able to store the data that we collect onto the cloud. In terms of the physical aspect of the device, our two most important features are the battery life and waterproofing of the device. So far, what we've been able to do is verify the tolerance of our heart rate to be within a tolerance level of 5 BPM, temperature of about 5 degrees, and our GPS location is less than 10 meters. Now these standards are all industry standards, so you'll see that our device will compare up to what's on the market right now. Finally, we are able to verify our IP68 waterproofing, as Connor will talk about later on. So examining our actual waveforms themselves from our PPG, which is here presented in, I believe, orange, you can see that the PPG data really aligns up with ECG data, and the peaks as well as different valleys very much line up. Looking at the instantaneous heart rate, we were able to verify that our BPM was within this tolerance level that we've decided. Now, moving on to Connor, he's going to talk about the IP68 standards and how he tested for them.
Yeah, so critical to our product's functionality is that you can just wear it and mostly forget about it. So it's really important that it be IP68 certified. We did a really quick, dirty, but I promise fully functional test. We submerged a mock-up device under a meter of water for 30 minutes. The way that we saw whether there was water ingress or not is we shoved the chem wipe in there. And the next slide, please. And then after 30 minutes, we took it out, weighed it again. It was exactly the same weight. Thus, we can conclude that there was no water ingress. Yep.
Yeah, so far as the device progress, we hit a few of our big milestones, mainly that we now, going off of what Connor said, have a new case that's waterproof. We also found and implemented a new smaller Tinsy microcontroller, which allows us to free up that arm box that you remember up on our elbow. So we got rid of that completely. We also implemented 3 sensors, a PPG, an IMU, and a force sensor for when you click the watch. And the watch got a little bit bigger to fit the battery. Next slide.
Yep. So we believe one of our products' most compelling selling points is actually its price. So like I said before, this is sort of a dumbed down version of a smartwatch that's a lot smarter in the important ways. And you can really see that reflected in our costs. Our 2 most important cost drivers are our comms module and our PPG sensor. Those are very high quality to make sure that you can get relevant data and that you can get it out to where it's needed, whether it's the caregiver, the first responder, et cetera. The rest of it is pretty much off the shelf components. And that's really borne out in our cost totals. We expect manufacturing the device, in a production environment, to cost somewhere between $30 and $45, which is really pretty good. So that would map to a possible market price of between about $40 and $80. That puts us pretty squarely in what we were aiming to get. The low end of the feasible market price we saw is about $42. So that's what Chinese industrial giants like Huawei are marketing watches like this for, with notably less functionality in the areas that we care about. And then we are very comfortably below what is sort of an acceptable entry-level medical device, which is what we're pitching. So that would be the $240. Yeah, next slide.
Yeah, so in terms of future plans, if we could continue to meet and push the design of the device, we would plan to use formulas to convert Alband's PPG data to dissolved oxygen. Next slide. We'd also want to design our own PCB so we can miniaturize our components. And we'd like to verify all that dissolved oxygen data with a pulse oximeter and refiner analysis. No, but fine. For us, what a successful senior design project looks like is not only that in June we could have a financially successful startup, but also that we're creating an affordable and accessible device for the people in need. If we think we've met that goal, and we're excited to show you that. So, thanks.
Yep. Thanks, everyone.